Hey there, everybody. Mr. Dickin here with our next lesson, our next installment, if you will, of rational expressions. And today we are going to be discussing multiplying and dividing rational expressions. These two operations, multiplication and division, go hand in hand. Now, as we discussed with our simplification, we cannot cancel individual terms. What I mean by that is this single 2 right here cannot cancel out or reduce with the 20. Not allowed. Since this is a factor, we have to look for entire factors that might be able to cancel. We also discussed yesterday excluded values, and those, of course, are anytime you see a variable in the denominator, we have to figure out what would be off limits for that variable. In this case, r plus 2, that factor is not allowed to be 0 because I can never have a 0 in the denominator. If we divide by 0, the whole universe implodes in on itself, and anything that you've ever known or loved will then cease to exist. So my excluded value for this particular example would be r equals -2. We can plug in any r value we want except for -2. All right, without further ado, let's go ahead and get going. First step we want to do is always factor these things out. Fortunately for us, everything is factored. Then, when dealing with multiplication, we can essentially treat this as one big fraction bar. And if I really wanted to, I could put little multiplication dots up top, down below. There's technically a little multiplication dot in between the 6 and these parentheses, between the 4 and the r. So I have a bunch of different pieces being multiplied together here. I have a bunch of different factors, if you will. So now when we go on our cancellation rampage, we can only cancel entire factors. So for instance, I see a 6 up top. That can cancel out with the 6 that I'm seeing down below. I'm seeing, let's see, an r plus 2, that entire thing can cancel out with the r plus 2 down below. This 4 right here, well, this 4 and the 20, those could actually reduce to a 5 and a 1. So 4 over 20 is the same as 5 over 1. This r can't really cancel out with anything since the r plus 2 is already gone. And even if it wasn't, we can't really cancel out individual pieces. So let me see what I have so far. I have a 1 up top and an r. Over, let's see, the 20 turned into a 5. The 6 is gone. It canceled out. The r plus 2 is gone. Yeah, it's just 1r over 5. And I totally missed the mark on that circling. Awesome. Now we're done. That's as pretty as it'll get. We might encounter situations such as this, where it's still multiplication, but now it looks slightly more terrifying. Well, just like we've done before, we're going to start off by factoring. You want to factor these things as far as you possibly can. The x plus 7, there's no parentheses listed, but if I really want to, I could put parentheses around them. That can't really factor down any further, so I have x plus 7 as an entire factor. X squared plus 3x plus 2, that'll factor down. Let's see, two numbers that multiply to 2 but add up to 3. Well, it'd just be 1 and 2. Or 2 and 1 if you have it written in a different order. That's fine. Multiplied by our second one here. Let's see, we have x squared plus 4x plus 3. X squared plus 4x plus 3. Two numbers that would multiply to be 3 but add up to 4. Well, that would be 3 and 1. 3 times 1 is 3. 3 plus 1 is 4. And underneath that we have x squared plus 9x plus 14. Two numbers that multiply to 14 add up to 9. We're going to factor this out. That becomes, let's see, that'd be x plus 7 plus 2. All right, so now we have this whole thing factored. As we've discussed before, we've got our excluded values, so we could go through and say off limits values of x, we're not allowed to use -1, we can't have -2, x is not allowed to equal -7 or -2, which we already said. So we have our excluded values. Now we look to cancel. X plus 7, I have another x plus 7 down below. Remember, we're canceling entire factors, not individual terms. Let's see, what else from the top can cancel at the bottom? I'm seeing an x plus 1 and an x plus 1. Now lastly, I'm seeing an x plus 2 and an x plus 2. These, however, cannot cancel because they're both in the denominator. If something were to cancel, you'd have to have one factor in the numerator and the matching factor has to be in the denominator. So you have to cancel one from top, one from bottom. So these two right here would not cancel out. So I'm left with, we have the x plus 3 in the numerator, and down below we have x plus 2 times another x plus 2. And if I wanted to, I could write that down below as x plus 2 quantity squared. So if I really wanted to, I could write it like that. I have that freedom. So that's multiplication. We factor and we cancel. That's it. So now let's turn our attention to the lovely world of division. Division is extremely similar to multiplication, however, it has one first step. In order to divide a fraction, dividing a fraction is the same as multiplying by its reciprocal. So what we can do is, instead of thinking of this as a division problem, let's think of this as a multiplication problem. But we have to use the reciprocal of that second expression. So instead of 2 over 4b, it's going to be 2 over 4b plus 10 over 2. The first expression will not change at all. So once we've flipped that second piece, ooh, and I'm smearing the joys of being a lefty. Once we've flipped that second piece, now this turns into the exact same concept as what we just got done doing. So we're going to go ahead and factor this beast out. Two numbers that multiply to be a negative 15, but add up to a negative 2. Those would be negative 5 and a positive 3. Down below, I don't see a squared. However, I do see a GCF of, let's see, 8 and 20. That'd be 4. So that's going to leave me with 2b plus 5. Now I'm going to take a little sidestep here. Remember, these 5s cannot cancel out. These 5s cannot cancel out because those are individual terms, not whole factors. And I'm realizing that I used x instead of b. Whoopsie daisy. All right, over here, 4b plus 10, another GCF. So between 4 and 10, I see a GCF of 2, which leaves me 2b plus 5. Ooh, that looks familiar. Foreshadowing, anybody? All over 2. All right, so now it's factored out. If I really wanted to, I could get my excluded values. So I could set this little piece equal to 0. What value of b is off limits? And that would be negative 5 over 2, negative 5 halves. Can't divide by 0, because if you do, the universe will implode in on itself, and everything you've ever known or loved will then cease to exist. And let's go on our cancellation rampage. 2s can go. The 2b plus 5s can go. And I think that's about it. So I'm left with the b minus 5 and the b plus 3 over, I'm just left with 4. And that will be my final answer. As always, if you have any questions, do not hesitate to reach out and ask.